All right, you guys, welcome. I am at the very bottom of the reading guide for 2.2. So very first couple examples in the 2.2 or 3.2, excuse me, chapter 3. Hello, notes packet. I have something for you to copy down right at the beginning. So AP exam tip, you will lose points when you are interpreting the slope, which you should have written in your reading guide up here, how to write a sentence that explains what the slope tells us about a problem, as well as the y-intercept also. But when you're interpreting the slope, there is a key word that you have to make sure you include. This is a very common error, and I see people lose points all the time for forgetting to put this into their interpretation. But you just have to keep in mind that we are using a y-hat. You can take a look at this example down here about the rats, where we are taking the amount of weeks that they have been alive and predicting their weight based off those number of weeks. And if you don't use the word expected or predicted, you are implying that we know exactly how much the rat is going to weigh if we know how many weeks old the rat is. So make sure that you're using that word. It's very important. I want to show you what that means looking down here at number 1. So we've got a scatter plot, and we have a linear equation to represent the scatter plot based on amount of time a rat is alive. And we've got a y-intercept and we've got a slope. So remember, y equals mx plus b. We use different variables in AP stats for whatever reason. But we've got a hat over the weight, which means we are predicting the weight. We don't know exactly how much the rat is going to weigh, because obviously there's a ton of other factors that go into a weight of a rat, but we can predict it based on the variable how much time it's been alive, and it's measured in weeks. Okay, so I have kind of a, just a side note, that 100, which is our y-intercept, right here, would represent birth weight, I guess. And then it goes up like so. So we've got a slope of 40. It's a positive slope. I didn't label my X or my Y, but this gives us an idea. And then we've got all these rats based on how old they are, that maybe they're going to fall close to the line. Some of them will fall really far away, etc. Okay, and we have a line of best fit that is a prediction. And that gives us an idea of how much we are expecting all of these rats to weigh, although it's not a guarantee. Okay, anyway, so what is the slope of the regression line? You guys know from Algebra 1, this number right here, 40, is the slope. And again, anyone in Algebra 1 can look at that equation and say the slope is 40. But hello, we're in AP Stats. Can you please tell me what that 40 means about the rats? And so here's what we're going to talk about. We're going to say, so the slope is the 40, and what we're going to say is, as we increase the amount of time, so for each additional week is another way that you've seen this. I don't know what you wrote in your reading guide about interpreting the slope, but there's a couple correct ways to say this. You need to talk about the increase, or for each additional, whatever the X value is in this case, which is time. Make sure you're including units whenever possible. Since birth by 1 week, we always increase the X value, whatever the X value is in context, by 1 unit. In this case, the units are weeks. There's my keyword expect. I am not guaranteeing that the rat's weight increases by 40 grams, but I'm expecting it to go up by 40 grams every single week. Hence, we have our positive linear relationship. Okay, so yes, you're going to have to write that sentence. You've probably heard it before in Algebra 1, but make sure that you've got that sentence so that you don't have to think about it. It's automatic. A similar thing for the y-intercept. So in Algebra 1, you memorize to plug in 0 for x in order to find the y-intercept. When x equals 0, the y-intercept is where the line crosses the y-axis. So here we have 100. It's represented by this number, the constant in the linear equation right there. What is the y-intercept? Again, Algebra 1, all my students can raise their hand and say 100. But AP Stats, do you know what the 100 tells us about the rats? And can you write a sentence explaining it? That is the point of stats. So here's our sentence. At 0 weeks old, at birth, we expect the weight of the rat to be about 100 grams. So that means when the rat is 0 weeks old, because what's 0 on the x-axis? We have it labeled down here as time. And so 0 in this case does make sense. Just keep in mind sometimes having a y-intercept of 0, depending on what the context is, it might not make sense. It might be considered something like an extrapolation. Just keep that in mind. But in this case with the rats, having a y-intercept of 0 does make sense. At 0 weeks old, that means when it's born. We expect the rate of the weight of the rat to be about 100 grams. Does that mean every single rat is born exactly 100 grams? No, it's a prediction. Very important, okay? Predict the rat's weight. I'm starting to like slur my words together. Predict the rat's weight after 16 weeks. Show your work. Okay, here's our formula. Predict the weight based on 16 weeks. So yes, it is as simple as plugging in 16 right here. So I'm going to write weight with a little hat over it because it is a predicted weight, not a guaranteed weight. 100 plus 40 times 16. When you plug in 16 for the amount of time, you get 740 grams. No big deal, okay? Should you use this line to predict the rat's weight at 2 years? When the rat survives to 2 years old, by the way, that's 104 weeks, 52 times 2, use the equation to make the prediction and think about the reasonableness of the result, okay? So again, weight, predicted weight, 100 plus 40, number of weeks would be 104. A pretty common mistake, again, be really careful, 2 years, can't plug in 2 here because in our problem we are measuring the amount of time in weeks. So make sure that you're plugging in the correct units into the formula. Anyways, when you plug this in, you get a pretty large number, which is 4260 grams. And I did tell you that there are 454 grams in a pound. No, you don't need to know that, but this means that we are almost 10 pounds, roughly. Okay, have you ever seen a 10-pound rat before? Hopefully not. That would be pretty freaky. So what is the point? Let me erase here. This is my work that I just showed, but almost a 10-pound rat. Our observations, therefore, our LSRL, did you catch in the wording? I intentionally kind of skipped over this. Some data were collected for the first 25 weeks. So they quit tracking these rats after 25 weeks. Therefore, to plug in 104 weeks to our equation, yes, we can plug in any number we want, but here in AP Stats, we need to make sure that we're not extrapolating. Here I have a very important vocab word, extrapolation. I do not want to assume that this trend continues beyond what we looked at, which was 25 weeks. Do you continue gaining weight at the exact same rate that you did when you were a baby? Probably not, my high school students. Same thing for a rat. This is a classic example of an extrapolation. We cannot stand behind this number. We do not want to see a 10-pound rat out there. This is an extrapolation. I do not know that my line continues beyond what we studied, which was 25 weeks. And actually, I'm pretty sure it doesn't continue like that. So just keep that in mind that yes, you can plug in any number to any formula you want, but when you're interpreting that value, you should probably be like, okay, now wait a second. First of all, this doesn't make sense. I don't want to see a 10-pound rat. Second of all, that's an extrapolation. I'm pretty sure we do not continue gaining weight at the same rate for our entire lives. Very important thing about that one. Put a star next to that. Make sure that you are never extrapolating. As I told you in class, that is one of the 7 deadly sins of statistics. We'll talk more about the rest later. Anyways, got a couple multiple choice questions for us to think about here. So for some reason, a lot of people forget that we have 3 specific formulas on our formula sheet that apply to this chapter. And I copied them here. Remember, you can find them on the formula sheet. We talked about them the first day of the chapter and we highlighted them, I think. But those will help you get multiple choice questions right, like these. So I have a couple like sample problems for us. I encourage you to pause the video and see if you can just kind of fumble your way through working with these formulas and see if you can get the right answer. But then you can play it and you can get the explanation. So anyways, I've got a y-hat equation. So this is a predicted y value. I don't know the slope, but I do know the y-intercept. And so I do know that if I look at these formulas over here, this is what's on the formula sheet. I believe the 3 is the b sub 0. I don't know why they use different variables, but they do. So my b sub 0 is 3. And I don't know what the slope is. It's m. I don't know why they didn't use b sub 1, but whatever. Doesn't matter what the variable is. If x bar and y bar, where did those come from? I do have a formula that uses both of those, so that's interesting. Which of the following is equal to y bar? So I'm going to have to get y bar in this equation. And I know the b sub 0, that's 3. And I kind of skipped over this point here, 2 comma 7. Let's use this equation and see what I know so far. So my b sub 0 equals y bar minus b sub 1 x bar. Okay, I don't know the slope. The b sub 1 is the slope. I probably have enough information to figure that out. It's asking me to find y bar. I don't know x bar either, but looking at my answers, there's an x bar in each of those answers. So I'm going to plug in 3 for b sub 0 because I know that. 3 equals y bar minus b1 x bar. Again, I'm just using this formula. Okay. Pretty sure that if I write this y-intercept as an ordered pair, it's 0, 3, right? Y-intercept, x is 0, y value is 3. There's another point. Maybe I can use that to come up with the slope. Isn't that the slope of the equation? B sub 1. Let's figure out the slope using this point and this point. So we do have enough info. So I have the point 2, 7 and the point 0, 3. So I'm going to do the slope formula really quick. I just use m automatically, but really we use several different variables for slope. But subtract the y values, subtract the x values. That's algebra 1. Okay, I got a slope. Cool. And I plug that 2 right there. So I've got 3 equals y bar minus 2 x bar. And it's asking me to get the y bar by itself. It's asking me which of the following is equal to y bar. I've got 3 plus 2 x bar equals y bar when you just move the negative 2x bar over. Oh, snap. Okay, I didn't even really know what I was doing, but I was just messing around with formulas, and I ended up with the answer, okay? These are on the formula sheet. You don't have to memorize them, but just know that they're there, and they will be useful in multiple choice questions like this. Second problem, let's see, I've got another y-hat equation, so I've got a slope of 3, and I have a y-intercept of 4, and remember that means 0, 4. That might help us. Okay. 4 values of the independent variable. Oh boy, do you remember that vocab word? Independent variable. And here's another one, dependent variable. So what depends on what? The x value is independent and the dependent variable is y. Let's see, what is the mean of the 4 values? So I need to find y bar. Okay, I'm going to use this formula again. Cool, so I'm going to copy that down real quick. B sub 0 equals, what was it? Y bar minus B sub 1 x bar. Okay, let's see what we know. The slope is 3. I got that from here, so I can plug that in right there. Do I know the y-intercept? This one? Yes, it's 4. Okay, cool. So I'm going to plug in 4 equals y bar minus the slope was 3 x bar. Why do I have these values? Those are the 4 values of the independent variable. Oh, I wonder if I average these together, I can get x bar. Oh, snap. Yeah, so if I take this and I average them, I believe you get, what was the answer? 28. Add them up, divide by 4, people. Average, x bar, sample mean for x's. These are the x values. Average them together in your calculator. Plug that in right there. And I think we're home free. We've got 4 equals y bar minus 3 times the x bar was 28 that I just calculated. Solving that equation gives us y bar equals 88. And I believe, again, fumbling my way through using these formulas, there are 3 of them that are on the formula sheet, will help you get some multiple choice questions correctly. So nobody panic. Those are weird questions. I really had no idea, like, why do I have to do this, right? We've got these formulas. Nobody panic. See if you can just plug in what you know, use what you know from Algebra 1 in order to find the slope if you might need to do that like we did up here. You can do it, okay? We've got some multiple choice problems that are going to be coming at you using these formulas, and those are a couple examples. Thanks for watching, you guys. We're almost done with the chapter. Let me know what your questions are. I'll see you tomorrow.